Hello everyone. In this video we'll be learning about binary search. As in the previous video we mentioned that there are two algorithms which we primarily use in order to search an array, and we discussed about linear search in the previous video, and in this video we'll be discussing about binary search. So primarily in this video we'll be answering these three questions. The first one is which one is more efficient among linear search and binary search. The second one is when to use linear search and when to use binary search. And the third one is how to implement binary search. So let's jump on to the first question, which one is more efficient. Binary search is commonly the more efficient approach. Let's see how that is the case. Suppose I have an array. Let's not create an array. Let's just write it down in comments. 1 2 3 4 5. Note that this array is sorted. So in linear search what we used to do is, suppose my target element is 5, I have to search for the index of number 5. Let's say my target is 5. So in linear search what we were doing is, we were searching each and every single element and comparing it with target. If it was equal to target, then we were returning the index value. So basically we were just using a loop in order to search for the index. But in binary search what we are going to do is, we are going to divide the search space in half every time we iterate. So let's see how we can do it. So the second question that's written over here is when to use linear search and when to use binary search. Let's tackle it. So here is an array 1 2 3 4 5, or here is a second array 5 4 3 2 and 1, and here is a third array 3 4 2 1 and let's say 5. Note that first two arrays are sorted. The first one is sorted in ascending order and the second one is sorted in descending order, and the third one is not sorted. It's like jumbled. So in the first two cases, the approach we are going to take in order to search these two arrays is binary search, and for the third one we are going to use linear search. So basically when you are given with a sorted array, just use binary search. And when the array is unsorted, just use linear search. As simple as that. So let's see now how we can implement this binary search thing. Suppose I have an array 1 2 3. Let's use our test case 5. This array is up to 5 starting from 1, and let's say my target is number 5. I have to search if the number 5 exists in this array. If it does, then just return the index of it. That's what we did in the previous video as well. So let me just create a function first. Let's name it as, what will be its return type? Its return type will be int, as it will be return the index, and let's name it as binary search. So we will use this array as our argument. So let's firstly understand the concept of binary search, what we are going to do in binary search. So as we know, every array starts from index 0. We know that every array starts from index 0, and the last index of every array is length minus 1. We know that last index of every array is length minus 1, You know that. So now we have got these two things at our hands, the starting index and the last index. Every other index is going to be in between these two indexes. So one more thing we need is we need the mid index. Like we need a mid element, like the mid of array. Let's see, 1 2 3 4 5. Starting index is 0 and last index is at 4. What will be the mid index? What will be the mid index? So mid index will basically be start plus end whole divided by 2. This will be our mid index. Or we can say start plus end minus start whole divided by 2. This will be our mid index as well. What are we going to do with this mid index? Like I'm mentioning here that we need mid index as well, but what are we going to do with it? So as I said earlier that in order to use binary search, the array must be sorted. As here you know, the array is sorted 1 2 3 4 and 5. This is our array. So my starting index is at 0 and my last index is at array.length minus 1. So it will be at 4, which is here. So my midpoint will be somewhere. Let's see what will be our midpoint. Start will be 0 and end will be 4. 4 divided by 2. My mid element will be at index 2. 0, 1 and 2. My mid element will be 3. Let's write it down over here. Mid element will be 3. Now I'm going to check if my target element is less than my mid element or greater than my mid element, which in this case is obviously greater than my mid element. Obviously 5 is greater than 3. So what I'm going to do is I'm going to shift my start to mid. Like I'm going to ignore these two. As I know that my mid is less than 5, my 3 is less than 5. As this array is sorted in ascending order, can't I just say that the elements before 3 are also less than 5? Like it's simple. If my mid element is less than 5, the elements before mid are also going to be less than 5 in case of the array is sorted in, if the array is sorted in ascending order. Quite simple. Now if my target index was 2, my mid will remain the same, my start will remain the same, and my end will remain the same. If my target index was 2, I will ask if is my target index less than or greater than mid element? Is my target element less than my mid element or greater than my mid element? It will be like it's surely less than your mid element. So what I will do is I will shift this last index to my mid. Makes sense? As all the other elements of the mid are going to be like greater than my target element as well, as this array is sorted in ascending order. Makes sense? So what I just said is, if my target element is greater than a mid element, what I will do is I will shift my start to mid plus 1. As I have already searched the mid is also less than my target element, so I will shift the start to over here. And if my target element is greater than my mid element, then my start will be equal to mid plus 1. Or if my target element is actually smaller than my mid element, then in that case what I will do is end will be equal to mid minus 1. Mid is already greater than my target element, so there's no point in searching the mid once again. So I will just shift my end index to mid minus 1, and in both cases the mid will shift accordingly. So it's basically all the theory that we are going to use in binary search. Let's code. Let's see how to code this. So firstly, as I said, my start will be from index 0 and my end will be equal to array.length minus 1 minus 1. So I'll use a loop, while loop. I'll say in here, while my start is less than or equal to end. I'll clarify why I'm using this condition over here. See, wait a second. Let me write it down over here. I have this array 1, 2, 3, 4 and 5. My target element is 5. So my mid element will be here 3. Target is equal to 5. My start is at index 0 and end is at length minus 1. And my mid will be at start plus end divided by 2. So it will be at index 2, which is 3. Index 2, which is equal to 3. So my mid element is 3. So in the first case, in the first search, what we will do is, this program will ask, is my mid element less than target or greater than target? It will like it's less than target. So what it will do is, it will shift my start to mid plus 1. Now my start will be at index 3, which is at 4. Start will be at 4 and my end will remain the same, and end will be at start will be at index 3, which is the element 4, and my end will be at index 4. Okay, what will be the mid over here? 3 plus 4 whole divided by 2, 7 divided by 2. 7 divided by 2 in integer terms is equal to like 6, is equal to like 3. So my mid will be at 3 as well. It will be like, once again, is my, let's write it down over here. Now my mid is also at index 3. As I said earlier, the mid will change accordingly. So my mid is also at like index 3, which is 4. It will ask once again, is my mid less than my target element or greater than my target element? It will be like it's greater than it will be like it's less than your target element. So once again, the start will shift from mid plus 1. Now start and end will be the same. Start will be at index 4 and end will also be at equal to index 4. Okay, now see here, as you can see, I have mentioned while the start is less than or equal to end. Start in all the cases above was less than end, and here the start is equal to our end. At this point, our loop will just break and it will return whatever is over here if it found the target. If it did not found the target, then we will create an exception for that as well. So this was basically the theory. Now let's code all of this. I will say while my start is less than or equal to end, I will say my mid element will be equal to start plus end minus start, end minus start, whole divided by 2. It's basically the same thing. Start and start will be twice start plus end minus start. This start and one from these start, this start will cancel out. Whole divided by 2, start plus end. start plus and hold divided by 2 basically be the same. So we have found our mid element. Now what we had to do is we had to ask if our target element was greater than our mid element or less than our mid element. So firstly I will say what's the best case in this search, like what could be our best possible result. Wait a second. Best possible result will be like we are just starting from our mid element, and our mid element is our target element. So I can just say if my array at mid is equal to target, then we have to create an argument for target as well. So if my array at mid element is equal to target, just return the index at mid, just return mid. First case, what we are saying is if my array at mid index is equal to target, just return the mid index. This will be the best case. Like in this search, you found the target element basically in the first try. Another case will be if my array at mid element is actually less than target. So what I'm saying is, see, I have like this array and my target element is 5, my mid element is 3. So is my mid element less than my target element? Yes, it is. So what I will do is I will just like shift my start from 0 to mid plus 1. I'll just do that. So start will be equal to mid plus 1. Or there is another case, if my array at index mid is actually greater than target. Suppose we have the same array and this time our target element is 2 but our mid element is 3 here. It will be like, is our mid element less than target or greater than target? It will be like your array at mid is greater than target. So what I will do is I will just shift my end from last index to mid minus 1. That's all I want to do. So my end will be mid minus 1. Okay, so that's pretty much it. That's the binary search. And in the end, if you didn't found out the result, just return -1, which means your target element wasn't found in the array. Just return -1. Cool. Now let's test this. Binary search, array and target. So what's our expected result? Our expected result is 4, as 5 is at index 4. As you can see here, we found out our result, which was as expected 4. Let's debug it for a second. Let's see how everything is working internally. So my start is equal to 0 and my end is equal to length minus 1, which is 4, as you can see here. My mid will be equal to start plus end minus start whole divided by 2. It will be at somewhere over 2. Mid is equal to 2. Now I'm asking if my array at is equal to mid. Array at mid is equal to target. Just return mid. It will check if my array at mid is equal to target. It will like no, it's not. It will move on to the next condition. In this condition, it will ask if my array at mid is less than target. It will like yes, it is. It will do start is equal to start plus 1. Previously the start was 0. Now my start is 3 as expected. So now my start is 3. End will not change, end will remain the same, but mid will change accordingly, according to this formula we wrote over here. So now my mid is 3, as I said earlier. Once again it will check if my array at mid is target. It will be like no. Move on to the next condition. It will be like is array at mid less than target. It will be like yes, it still is. So once again it will be like start is equal to mid plus 1. Now my start was 3 and mid was also 3. Now my start will be equal to 4 and end will also be equal to 4. It will once again check all the conditions. Keep in mind, this is our last iteration now. You can see mid is at 4, target is at 5. Mid is also equal to 4. Now see here, start is 4, end is 4, and mid is also 4. All the 3 indexes are basically the same. So that's what we are doing. The condition which will find the answer is just this, the first one. Now, as I said, mid will keep on shifting accordingly, and in the end, start, end, and mid will all be equal to each other. So it will return mid, target 5, target found at array at index 4. Now it will print the mid, 4. So that's all about binary search.